Hello students, myself Manoj Kumar. Today I will discuss a paper of BSc 5th semester, that is linear programming. In this lecture we will discuss about the graphical method to solve any linear programming problem. Here first of all we discuss about the mathematical description of a general linear programming problem. First of all, we discuss a general linear programming problem can be stated as such that we will discuss a function which is linear. We have to find the maximum or minimum of that linear functions such that maximum or minimum of z is equal to, that is, here we will take a linear function for which we have to find the maximum or minimum values such that z is equal to c1x1 plus c2x2 plus c3x3 and plus so on plus cnxn. So this function, that is maximum or minimum of z is equal to c1x1 plus c2x2 plus c3x3 plus so on cnxn is called the objective function. So this is the objective function. We can write this as objective function. Objective function. And there are some inequalities or inequations such that a11 x1 plus a12 h2 plus a13 x3 plus so on plus a1n xn is less than or equal to, here less than or equal or greater than or equal to b1. There exist two signs, two inequalities. This becomes less than or equal or greater than or equal to b1. And similar, a21 x1 plus a22 h2 plus a23 x3 plus so on plus a2n xn is also less than or equal to or greater than or equal to b2. Similar, we can write a31 x1 plus a32 h2 plus a33 x3 plus so on plus a3n xn is less than or equal to or greater or equal to b3. So on, there exist many constants such that an1 x1 plus an2 h2 plus an3 x3 plus so on plus ann xn, and this is also greater or equal to, less than or equal to or greater than or equal to bn. So there exist these inequalities, and these inequalities are called the constants. These are called the constants. And last is such that xi's or greater or equal, there exist restrictions. This is also called non-negative restrictions. So this is a mathematical formulation of any linear programming problem. Here we will discuss how to solve this type of problem by the graphical method. Now first of all, what is the solution of an L.P.P? If c1x1 plus c2x2 plus 1 cnxn, and this is the objective functions, these are constants, and this is non-negative ds. What is the solution set? यदि मैं solution set की बात करूं तो solution sets क्या होते हैं? तो सपोज करिए x1 x2 so on xn, तो कुछ ये वैल्यूज होंगी x1 x2 so on xn की। ये वैल्यूज सपोज करिए x1 की कुछ वैल्यूज होंगी एज लाइक 1 2 3, इस तरीके से कुछ भी हो सकती है। तो ऐसी वैल्यूज x1 x2 so on xn की वो वैल्यूज जो इन कॉन्स्टेंट्स को सेटिस्फाई कर रहे हैं। कहने का मतलब है कि x1 x2 so on xn की वैल्यूज जो इन कॉन्स्टेंट्स को सेटिस्फाई कर रहे हैं, दैट इज इनकी इनइक्वालिटीज को सेटिस्फाई कर रहे हैं, then this set is called the solution set of an L.P.P. Then this is called the solution set of an L.P.P. Okay, so now this is a solution set of L.P.P. if this satisfies the constant of an L.P.P. इसको लिख लीजिए, if it satisfies constants, तो ये सिर्फ कांस्टेंट को सेटिस्फाई करें ये, तो इसे क्या बोला जाएगा? दिस इज कॉल्ड द सॉल्यूशन सेट ऑफ L.P.P. नेक्स्ट इज व्हाट इज द फिजिबल सॉल्यूशन? व्हाट इज द फिजिबल सॉल्यूशन? आप सपोज करिए ये हमारा जो सॉल्यूशन सेट है, यदि ये कांस्टेंट को भी सेटिस्फाई करे और साथ ही साथ ये इन नॉन नेगेटिव कंडीशंस को भी सेटिस्फाई करे। कहने का मतलब यदि ये जो हमारा सॉल्यूशन सेट है इस कांस्टेंट, सारी जो कांस्टेंट की इक्वेशंस हैं उनको सेटिस्फाई करे और साथ ही साथ इन नॉन नेगेटिव रिस्ट्रिक्शंस हैं इनको सेटिस्फाई करे, तो यही जो सॉल्यूशन सेट हो जाता है, यही जो सॉल्यूशन सेट है, दिस इज कॉल्ड द फिजिबल सॉल्यूशन। इसे क्या कहा जाएगा? देन दिस इज कॉल्ड द फिजिबल सॉल्यूशन। ना, तो ये तो हो गया आपका फिजिबल सॉल्यूशन। इफ दिस सॉल्यूशन सेट satisfies the constants, non-negative restrictions, and also gives the maximum or minimum values, if it satisfies this, that is it gives maximum or minimum values, and also satisfies these two conditions, then this solution is called the optimal solution। तो कहने का मतलब ये है कि एक ऐसा x1 x2 so on xn का सेट ऑफ वैल्यू, ऐसा वैल्यू सेट जो सिर्फ कांस्टेंट को यदि सेटिस्फाई कर रहा है तो उसे सॉल्यूशन सेट कहा जाएगा। यदि वो कांस्टेंट के साथ साथ नॉन नेगेटिव रिस्ट्रिक्शंस को भी सेटिस्फाई कर रहा है तो उसे फिजिबल सॉल्यूशन कहा जाएगा। और यदि वो इन दोनों के साथ साथ सेटिस्फाई करने के साथ साथ इसकी ये जो हमारा ऑब्जेक्टिव फंक्शन है इसको ऑप्टिमाइज कर रहा हो, ऑप्टिमाइज मीन्स मैक्सिमाइज या मिनिमाइज कर रहा हो, तो इसी सॉल्यूशन को ऑप्टिमल सॉल्यूशन कहा जाता है। सो दिस इज ऑल अबाउट सॉल्यूशन सेट, feasible solution and optimal solution. Now we will start the graphical method. There are some steps which is used to solve any problems by the graphical method. There is first step. Step first. In step first, we will convert the constants into the equations. That is, if there are these signs, we replace inequalities as like less than or equal to or greater than or equal to by equality. That is if we have a constant such that a1 1x1 plus a1 2x2 plus so on plus a1n xn is less than or equal to or greater than or equal to b1 or any number b1, then we replace these inequalities by equal. That is a11 we have a constant, then we replace it by a11 x1 plus a12 x2 plus so on plus a1n xn is equal to p1. That is, this inequality can be replaced by an equation. Next, this is called step first. Now next is step second. In step second, we will draw the graph of these linear equations, that is lines on the coordinate axis. That is, if we have the constants such that a1 1x1 plus a1 2x2 plus 1, that is basically this method is used for two variables. So we will draw the lines in plane corresponding to each equation obtained in step first. So draw the graph of each equation into the plane. Okay. Next is step third. In step third, we will show the feasible region, that is that region in which the solutions satisfied the constants and also non-negative restrictions. So we have to choose the feasible region. So this is the step third and last step. In last step, which is step 4, we have to find the extreme points. What is the extreme points? What is the meaning of extreme point? That is corner point. This is also called the corner points. And check the objective functions, optimal solutions for that extremal points. So in last step 5, we check the values at these extreme points, extreme points, and find optimal solutions. Optimal solution. So these are some steps to solve a linear programming problem by the graphical method. A question: solve L.P.P. Here L.P.P is your maximum of z is equal to 48x1 plus 40x2. This is your objective function, that is maximum of z is equal to 48x1 plus 40x2. Now such that with respect to such that there are constants such that 2x1 plus x2 is less than or equal to 90, and next is x1 plus 2x2 is less than or equal to 80, and third is your x1 plus x2 is less than or equal to 50, such that there are non-negative restrictions such that x1 comma x2 is greater or equal to 0. So this is a problem. We have to solve this by the graphical method. First of all, we start step by step and solve this problem. The first step is first of all we replace these inequalities by the equal sign. So this inequality becomes 2x1 plus x2 is equal to 90. Again, this inequality becomes x1 plus 2x2 is equal to 80, and last is x1 plus x2 is less than or equal to, that this is also equal to 50. Now we draw these equations on the plane, that is xy plane. Here it is given that this restriction is, that is x1 comma x2 is greater or equal to 0. So we take only first quadrant, that is this quadrant, where this is denoted by x1 and this is x2. Now we draw this equation of line on the plane, that is if we put x1 is equal to 0, so if x1 is equal to 0, then x2 is equal to 90 degree. So this point becomes 0, 90. Again, if x2 is equal to 0, so if x2 is equal to 0, so x1 becomes 45. That is, so point becomes 45, 0. Now, next is your f. This is equation first. This is for equation first. This is equation first. This is equation second. This is equation third. Now, this is for equation first. Now, for equation second, if we put x1 is equal to 0, so x2 is equal to 40. So point is 0, 40. Now, if x2 is equal to 0, so x1 becomes 80 and point is 80, 0. Again, if we put x1 is equal to 0, now for the third equation, this is for first equation, this is for second, and this is for third equation. If we put x1 is equal to 0, so x2 is equal to 50. So point is your 0, 50, and now if x2 is equal to 0, so x1 is also equal to 50. So point is 50, 0. Here we see that these are very large values, so we took the interval 20, 20, or we can take length of interval be 15. So if we take the length is 20, so this becomes 20, this becomes 40, this becomes 60, and this becomes 80, and this becomes 100. Now similar on the x2 axis, that is this is 20, this is a 40, this is a 60, this is 80, and this is 100. So now if we draw these points on the coordinate plane, so we get first point is 0, 90. So x1 is 0 and x2 is 90. So this point is 0, 90. Now second point is 45, 0. That is this point becomes 45, 0. So if we meet these 2 points, so this is your line, this is your line, this is 2x1 plus x2 is equal to 90. This is your 2x1 plus x2 is equal to 90. Now second line is x1 plus 2x2 is equal to 80. So draw this point. First is 0, 40. That is this is your 0, 40, and next is 80, 0. So 80, 0 is this point. So after this is your second line. That is this line is x1 plus 2x2 is equal to, that is x1 plus 2x2 is equal to 80. Now for third line, x1 plus x2 is equal to 50. That is this is your 0, 50 and 50, 0. So this is yours 0, 50, and this is your 50, 0. This is your 50, 0. So after meeting, after joining these points, so we get this. Okay, this is your graph of these lines. This line is your x1 plus x2 is equal to 50. x1 plus x2 is equal to 50. Now if we give the names of extreme points, that is corner points. So suppose this is your A, this is your A, this is your B, this is your C, this is your D, this is your E, and this is your O. So if we take the feasible region, what is the area in which we get the feasible solutions? First of all, we take the area. Here it is given that 2x1 plus x2 is less than or equal to 90. So the value is less than or equal to 90. So we draw an arrow on this. So this is lying over 2x1 plus x2 is less than 90. That is, this is this area, this describes this area, this total area. So we draw our arrow on this line such that now if we take the second line, that is x1 plus 2x2 is less than or equal to 80, so this is your this line and we draw this as this. So we take third line, that x1 plus x2 is less than or equal to 50, that is this is this area. So what is the common area in these lines? So this is your feasible region. This is your feasible region. This is your feasible region. That is this. This is your feasible region. Now we have to show or analyze the extreme points. Here extreme points are A, E, D, B and O. Here now O is 0, 0 and B is your that is this is your B, and B is your 45, 0. This is your B and this B is your 45, 0. So this is your B and B is your 45, 0. Okay. This is your B. Okay. This is your B and B is 45. This is C. C is 50, 0. So not confused from this, because this is 50, 0 and this is 45, 0. So this point, so here we have the points. A is first of all 0, sorry, O is 0, 0. That is B is your 45, 0 and A is your 0, 50, 0, 40. And now we have to find the solution of E and D. Here we see that E is the intersection of this line, this, that is x1 plus x2 is equal to 50, and this line, that is x1 plus 2 x2 is equal to 80. So this point E is the intersection of these two lines. So solving these two equations, if we solve these two equations, that is x1 plus x2 is equal to 50. If we solve x1 plus x2 is equal to 50 and x1 plus 2x2 is equal to 80. So we have solved this. X1 and x2 cancel out. If we subtract this, x1 and x2 cancel out. So this is minus x2 is equal to minus 80. So this is x2 is 30. x2 is equal to 30. Again put the value of x2 is equal to 30. So x1 is equal to 20. So this point is your 20, 30. So point E is your 20, 30. Similar, if we if we find this point, that is D, so this point D is the intersection of x1 plus x2 and this line, x1 plus x2 and this line. So after solving these two equations, if we solve these two equations, so we get point D. After solving these two equations, so subtracting this, x2 and x2 cancel out, 2x1 minus x1, that is x1. So x1 is equal to 40. So this point D is your D point is x1 is your 40. After putting the value of x1 40, so x2 is 10. So these are your extreme points, that is 0, 0, 45, 0, 0, 40, 20, 30 and 40, 10. These corner point or extreme points are called the feasible solutions. These are called the feasible solutions. So these are the feasible solutions. These are feasible solutions. So we have the feasible solution is this. Now we have to find the optimal solution. Now for optimal solution, that is, we have to put these values in this equation at that values for which we get the maximum value, then that solution, that feasible solution is called the optimal solution. So first of all, we put O, this O point, so we get Z is equal to 0. The maximum value, the value of Z is equal to 0. Again, we put point B. If we point B, that is x1 is equal to 45. So value Z is equal to become 48 into 45, and this becomes 0. So this is 0. So after multiplying, we multiply this. So we get 540. 5 4 is 20, 24, 4 is 32, 4 4 is 16, 3 19. So 0, 6, 11 and 2, that is 2160. So this is 2160. Again, if we put this value, so for this is for point O, this is for point O, this is a for point B, and this is a for point A. If we take the value for point A, we get Z is equal to this is 48x1, that is 0, plus 40x2, that is 40 into 40, that is 1600. Again, for point E, we get for point E is we get Z is equal to 48 into x1, that is 48 into 20 plus 40 into 30. So we get 0, 16 and 9 plus 1200, that is 0, 6 and 2 9 11, 1 1 2 2160. This is also 2160. Now if 40 comma 10, if we take the value for 40 comma 10, so we get for point D point, so this is a 48 into 40. So for point D, Z is equal to 48 into 40 plus 40 into 10, that is, this becomes 0, 19 plus 400, that is, this becomes 2320. That is 2320. So here we see that for Z is equal to 0, for point O, Z is equal to 0, for point P, Z is equal to 2160. This is this. So we see that the maximum value is for Z is equal to, so maximum value is this, for point D is equal to 40 comma 10. Hence 40 comma 10, that is x1 is equal to 40 and x2 is equal to 10 is the optimal solutions.